بسم الله الرحمن الرحيم. نكمل tutorial of unit 5. We have two questions left, question 3 and question 4. طيب, question 3, using structural modeling with a bottom-up design methodology, write the Verilog HDL description of a 3-bit adder subtractor circuit. You need to follow the approach outlined below. A is draw the circuit at high level using block diagram where necessary. Okay. For a 3-bit adder subtractor, طيب, the adder subtractor circuit, you need for 3-bit, that means I need 3 full adders. I'll have inputs AB for each adder, AB, and I have CN, 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 and we also have C out, and C out. Okay. طيب, I'll have S of 0, S of 1, S of 2, and final carry out. I have A0, A1, A2, that's the 3-bit number. Now, for a 3-bit adder, you can attach B0, B1, B2. But for an adder subtractor circuit, we know that to compute A minus B, we need to change that to A plus B's 2's complement, which is equal to A plus B bar plus 1. So instead of attaching B directly to the input B of the full adder, we're going to use an XOR at each input. And we attach B0, B1, and B2. Now, for the second XOR input, all these will be connected to the CN signal, and I'm going to call this signal add subtract. Or to be precise, add bar subtract. Also connect the carryouts to the carry-ins. Okay. So if add subtract equal to 0, CN will equal to 0, and all these will equal to 0. So you will have B0 XOR 0, B1 XOR 0, and B2 XOR 0. From Boolean identities, we know that anything XOR 0, it's going to be the same. So that's going to give me B0, B1, and B2. In the end, that's going to add A0, B0, A1, B1, A2, B2, and give me S2 to S0 plus the carryout. So this is the addition. So if you want to add, we're going to place the signal to the add bar subtract signal will equal to 0. This is the addition. Now, for this signal, if it was 1, what's going to happen is carry in will equal to 1. And I'll have B0 XOR 1, B0 XOR 1, sorry, B1 XOR 1, B2 XOR 1. And anything XOR 1 is going to give me the complement of it. So that's going to give me B0 bar, B1 bar, and B2 bar. So what's happening here is A plus B bar, which is the output of the XOR, plus 1. This one is coming from the CN. Okay, so this is equal to A minus B. So this is the high level adder subtractor circuit. Okay, that's part A. Now, for part B, define a module of a half adder using built-in gate primitives. We need to create a half adder and define a second module of a 1-bit adder subtractor by, so this is a full adder subtractor circuit. And then finally, we define the third module, which is this one. Okay, so we will do half adder, full adder subtractor, and then the 3-bit adder subtractor, right? Remember that we need to use structural modeling. So we're going to be calling in functions to each other, or calling in modules to each other. Let's jump to our code editor. Okay, first we need to define the half adder. We have, let me draw it first. The half adder is, I'll do it here. It will take 2 bits A and B, AB, and give me sum and carry out. This is the half adder. So all I need to do is make the module for that. Module half adder. We have 2 inputs, AB, and we have 2 outputs, S and C out. Input AB, each is 1 bit, and I have output S and C out. And then I'm gonna use XOR, let's call it X1 for the instance name. It's gonna output S. Remember to put the output first and then route in AB. The same signal is gonna go into the AND gate, but it will output S, sorry, this will output C out, and will take AB as input. Okay, so this is our full adder. Now from that, we need to create our full adder subtractor circuit, which will take in A, B. Instead of CN, we're gonna call it add sub, and we have 2 outputs, S and C out. So before we write the module, let's draw the diagram. So I'll have a half adder, another half adder. For this one, we're going to take in A and B, and then the sum bit will be routed to an input of this half adder, CN, which we called it the add sub. Let me do the full adder, the regular full adder first, and then we modify it to make it an add sub circuit. So CN should go into input B. I have S and C out from here. Now this is going to be our final S for the full adder, and I'll take these 2 signals routed to an OR gate, which will give me C out of the full adder. Okay. Now if I want to make this an add subtract circuit, instead of, I need to modify B to make it XOR. So let's have an XOR here. So XOR with the add sub signal. Yeah, and then the CN here is going to the B input. Okay, so all I need is to add the XOR signal at the input B. Okay, so let's write that. We need two half adders. We need to create some wires. CN doesn't need a wire, so I need a wire here. Let's call this W1, and I'll call this W2. Okay, let's go back here. So my full adder subtractor circuit, I have input A, B, add sub, and output S and C out. I need two wires. We called it W1 and W2. Okay, let's first do the first full adder. Sorry, the first half adder, or maybe the XOR. I need the third wire. I need this wire here. Let me call it W3. Okay, so I need an extra wire, W3. Now let's do the XOR. That's gonna be XOR X1, which take B and, sorry, it's gonna output W3 first, and then we'll take B and the add sub signal. Now let's declare the half adder, call it H1, and we should follow these signals here. So for input A, we're going to have A that's coming from the input. Input B will have W3. The sum will be W1. And C out will be W2. Okay, let's make the second half adder to the right. That's going to take in W1 as input A. It's going to take the add sub input signal as input B, and will output S. I need a fourth wire, which is W4. This is W4. Okay, so add the wire W, W4. Give me S and W4 for the carry out. Okay, now all I need to do is the final OR gate, which will output C out and takes input of W4 and W2. Okay.
يا دكتور،
تفضل.
الانبوت ما في سي ان انبوت ولا؟
في الادر subtractor ما في CN لانه CN will be used as the add sub signal.
اوكي.
لانه if you are adding two numbers, CN should be 0. Now, if you're subtracting two numbers, you need A, you need B bar, and you need to add 1. So you're going to use CN equal 1. And at the same time, you need to complement B. So the way to do it is to have this XOR here at input B. So you can complement whenever you want to subtract. So this one at the subtract is going to go into CN of the whole full adder. Plus, it's going to complement B. So it will give you A plus B bar plus 1, which is A minus B. Okay. طيب. Now, let's do the final adder subtractor. So I'll call it, let me call it add sub. This is the final adder subtractor, 3-bit. I'll have A, B, the add sub signal, and I'll have two output, S and C out. So my input A is 3-bit, so that's A, and then have A and B. AB. I have the output is 2 to 0. This is for S. I have input at sub. This is the first circuit that we did in the Word document. I have also one output C out. One output C out. Do we need wires? We need wires. I think mainly we need wires just for the carry out and the carry in. So let's make that, let's call them C1 and C2. I only need two of them. Okay, here is what I'm trying to say is you have the full adder subtractor. You have those. This is add sub signal, and then I need to make these two wires. So this is C1 and this is C2. Okay, here we're gonna route A0 B0. Here we're gonna route A1 B1, and here we route A2 B2. Okay, so I need three full adders, two wires. That's it. So my full adder is called FAS, full adder subtractor. Call it F1, and then need to pass these signals in order if you want to avoid port name declaration. So for A, we're gonna pass A0 for the first one. We're gonna pass B0 for the second one. We're gonna pass add sub as the CN or the add sub signal. I'm gonna get S0 and C1 for the output. That's the first full adder. Second full adder should take A1 B1 and should take the add sub should be, wait.
C1 ولا
لا
C1.
ثواني، دقيقة، في مشكلة، في مشكلة. لأنه الإكسور هذه that's going to the B should not be XORed with C1. It should be XORed with this signal. Okay, so I need to make two signals for the add sub. هنا ما أقدر أستخدم هذا الديزاين. الآن CN should go to this one definitely، ولكن هذه حأفصلها. هذه حتصير الاد sub signal in my full adder subtractor. Okay. ليش؟ لأنه إذا هذه 1 تمام I need to apply it to all full adders. If the result of the first full adder is 0 for the carry out حيصير عندي B، ما حيصير عندي B bar، بس أنا أحتاج B bar للجميع. لذلك حفصل هذه السيجنال and I will have just a regular CN here. So I have add sub. I need to add another input which is CN. Let's put it here. Need to declare it as an input CN. XOR will take XOR W3 B and add sub. That's fine. The first half adder A W3, yeah, A W3 will give me W1 and W2. Second half adder will take W1 and CN instead. Okay, will give me S and W4, and then the last one is not gonna change. Okay, ففصلت ال CN عن ال add subtract. Okay, now each full adder subtractor need these two signals. So for this full add subtract A B C N, I need to add CN here So the first CN and the first add sub is going to be the same. For the rest of them, CN here is going to be C1, and add sub is just going to be the same that's coming from the input. So the add sub is going to the XOR. CN that's coming to the actual addition. Okay, this is going to give me S1 and will output C2. If you got confused, let me know so I can repeat the the modification that we did. So third full adder, this will take A2, B2, and C2 as Cn. The same add sub signal is going to the XOR with B, and this will give me S2 and the final carry out. Okay, so what we did, this is the bottom-up approach. We started with a half adder and then built in the full adder subtractor, and then we built the 3-bit adder out of that. Okay, let's test. Let's check what the question needs. So define a second module, define a third module, saying necessary a number. طيب, it did not ask to test it, ولكن we can do it. Let's write down a quick test for that. I need, let's take those here. So my input has to be declared as regs, and my output should be declared as wires. This is a wire, and this is a wire. This is for the test bench. Okay. هذا طبعا ما له علاقة فيه لأنه داخل الموديول. Okay, and then we need to make an instance of that at subcircuit. I'll just take this as I see it here, but we need to give it an instance name, which is UUT, meaning unit under test. We're gonna put A, B, add subtract, and get S and C out. Okay, so let's make a quick test. Let A مثلا be, this is a 3-bit number, so A is equal to 001, B is equal to, B is equal to, let's make it 010, أو العكس خلي هذه 11 مثلا وهذه 1. Okay, so A is equal to 3 and B is equal to 1. Let the add subsignal equal to 0, meaning we want to add. Let's make 1 nanosecond delay to see the answer. And then next case, we need to test the subtract. So let add sub equal to 1. We should get S here equal to 4, which is 100. And this one, we should get 010, which is 2. So 3 minus 1 is 2. And here 3 plus 1 is 4. Hopefully it will work. Let me see, A, B, and then the add sub signal. Let's watch S and then see out. Okay, so first case, we have add sub equals 0 means we want to add, so 3 plus 1 is equal to 4, carry out is equal to 0, so that's correct. Second case, we are subtracting 3 minus 1, we should get, is there a delay here? I can see 2. Why is it not writing 2 here? Ah, إلا صحيح صحيح. So this is the value. So 3 minus 1 is equal to 2 when the out sub signal is 1. If you want to test more cases, we can do that, but these two cases should be enough. Okay, so our circuit now is working fine. This was tutorial 5, question 3. Okay, for the fourth question, this problem is comprised of the following two related questions. Using a user-defined primitive of your own creation with minimal number of rows, explain how to design a simple magnitude comparator of two inputs, A consisting of A1, A0, and B consisting of B1, B0. The magnitude comparator output result is an active low output, providing an output of 0 only when A is greater than or equal to B. Okay. Write a test bench module in Verilog to test the above UDP. Let's write the UDP first. So to write the UDP, we need the truth table. So let's write the truth table first. الدائرة بسيطة عبارة عن magnitude comparator. عندي 4-bit input, 2 of them for A and 2 of them for B. And we need to make the output 0 only if A is greater than or equal to B. Okay, so I have 16 cases because I have 4-bit input. That means 16 cases. You know what? I think it's easier to write in a table. So let's go back to the Word document. Let's make a table here. I need to insert a table with, I need 16 rows. This should be 5, I think. Oh, 17 rows and 5 columns. So this is A1, B1, sorry, A1, A0, and B1, B0, and then the output result. Okay, so I need to write all the combinations. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. I'm just writing all the combination from 0 to from 0, 0, 0, 0 to 1, 1, 1, 1. This one is just okay. Now note that A1, A0, this is a number by its own. So let's make this, oops, no, that's not what I meant. وين اللي هي تبع التابل نفسه؟ Yeah, so this is a number and this is another number and we are comparing A and B. Okay, so if A is greater than or equal to B, the result should be 0. This is what's saying here. The output is active low, providing an output of 0 only when A is greater than or equal to B. So for this case, 0 compared to 0, this is equal. That means output is 0. For the rest, B is greater than A. Here B equal 1, B equal 2, and B equal 3. Compared to 0, B is greater than A. So these three should be 1s. Now 1 compared to 0 is A here is greater than B. Here A is equal to B, so that's also included. Now 1 compared to 2, B is higher, and here B is higher. Here A is higher and equal for these three cases. In this case, B is going to be smaller. Sorry, B is going to be higher. So this should be 1. Now the last four cases all will be, sorry, should be 0 because A is greater than or equal to B. Okay. Now you can go ahead and write these in a table in a UDP just as we saw in class. ولكن السؤال طالب منك انك تستخدم the minimal number of rows. So we need to find a way to reduce those. Um, for example, check these four lines. Regardless of the value of B, I have A, if A1 and A0 equal 1, 1, I always have the output as 0. Okay, so for these four cases, what I can do, instead of writing four lines, I can write 1, 1, and then here just B and B. What does B mean in UDP table? It means either 0 or 1. So this line here will take off these four lines. Okay, so let's مثلا this is, so this can be shortened to this line. Let's check, for example, what else can we do if we have, so here we can also reduce these to two lines, and we can reduce these to, sorry, these two can be reduced to one line, and these can be reduced to one line, taking 3-bit. So if A equals 0, A0 equal 1, and B1 equals 0, it doesn't matter what the value of B0 is, the output is always 0, and here the output is always 1. بالتالي let's take these two lines and reduce it to 1, sorry, 0, 1, 0, don't care. This should give me, so this one should give me 0, and this one should give me, should give me 0. Yep, this is the blue line. Now these two, let's make them, I don't know, purple maybe. In case we have 0, 1, 1, don't care, the output is always 1 for that case. Now we took off 8 lines and replaced them with 3 lines. What else can we do? For example, how can we reduce these into, can we do it in a single line? No. We can reduce those. If you have 0, 0, 0, if you have 0, 0, 1, regardless of the value of B0, I get 1, 1. So these two can be reduced. So instead of those, I will write 0, 0, 1, don't care. This will give me the value 1. Okay. I also have these two lines. Sorry. These two lines. Brown. So these two lines is 1, 0, 1, 0, 0, and don't care. 100, regardless of the value of b, I'm gonna get 0 at the output. So this is another shortcut. These I cannot change. Maybe let's check this one and that one. Is there something common between them? We only have, no. What about this? No. Okay. So instead of using this whole table, I can reduce it to 1, 2, 3, 4, 5, 6, 7, 8, 9. So instead of 16 lines, I can write it into 9 lines. Okay, so the final table should look, I just need to add these cases. Let's write it in the code right away. Okay, so we have these lines plus these 2 lines and these 2 lines from here. Okay, so this is a magnitude comparator which takes in A, B, let's make it A1, A1, A0, B1, B0. Need to list the output first اللي هو result. Okay, so this is not a module, this is a primitive, and it should end with end primitive. We have output result, then we have input A1, A0, B1, B0. That's it. Then I should write table, end it with end table, and start plugging in the values. So according to this order, we have A1, A0, B1, B0. That means this is the order that we're gonna follow. Okay. First 2 line, that's 0, 0, 0, and 0, 0, 1. So 0, 0, 0, 0 should give me 0. And then this case should give me 1. And then I can write these 2 lines 1, 0, 1, 0 and 1, 0, 1, 1. So 1, 0, 1, 0 and 1, 0, 1, 1. This is 0 and this is 1. Okay. For the rest, I'll just take it from here. So I have 1, 1 BB will give me 0. 1, 1 BB will give me 0. And then let me just copy and paste. I'm just fixing the format. Okay, now this should be ready. Let me just check the syntax. Um, if there's a test bench, that's fine. Okay, so the error about the finish. Oh, shouldn't have end here. Why are you mad? Okay, so no errors. طيب. So this is part A of question 4. We wrote this, I believe, in the minimum number of rows that we can do. We reduced these 4 into one line. We reduced these two to one line, these two to one line, these two to one line, and these two to one line. Okay, so we took off about 7 lines from the 16 lines here. Okay, so that's part A. Now, for part B, write a test bench module in Verilog HDL to test the above UDP, where simulation starts at 0 nanosecond when all inputs are 0 and remains so for 10 nanoseconds. Okay, then forward the simulation time to only cover the even valued input combinations determined by an even row number in the original truth table. Okay. The duration of the simulation for each input combination is equal to a multiple of 5 nanosecond of the decimal equivalent value of that input combination. This is a complication that really is not necessary. But to explain, maybe we don't have time to write it, ولكن to explain what it means. First, we will test طبعا it's not asking to simulate all values for A and B. So not 16 simulation. We just want a few of them. So it will start at this value. Let me add, I want to add a column to the left. Okay, so this is 0, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, and 15. Okay, so it's asking to start with this case, which is 0, 0, 0, 0, and then case 2 is 0, 0, 1, 0, case 4, case 6, case 8, case 10, 12, and 14. So this is the even valued input combination that it's talking about. تمام. أول input combination should stay for 10 nanosecond. We know how to do that. بعد كده كل input combination مثلا هذا اللي هو 2 should stay for a multiple of 5 nanoseconds. So we need to multiply that by 2. Okay, I think it's more. I understand the complication now. Since we're out of time, let me move this to the next class because I think in order to implement this, we need to write a loop. I don't think we can do it. Yeah, if we do it just يعني يعني اقدر اكتب a1 equals 0 a0 equals 0 b1 equals 0 b0 equals 0 and then pound 10 بعدها I place the value ارجع اكتبه مره ثانيه a1 equals 0 a0 equals 0 b1 equals 1 and b0 equals 0 I multiply this by 5 so I get I'll still get 10 so I'll make pound 10 بعد كده هذه will be pound 20 this will be pound 30 pound 40 and so on. I think there is an easier way to do it using loops. So I'll write it down for you. If we need to mention it in the next class, I will do. ولكن I'll just write the code, and if I receive many questions about it, I'll explain it in the first يعني in the first few minutes of next class. Okay. في أي سؤال؟